Here, so this is reduced in size, using the equipment that Frank has got in the larger barn. And then that goes into the heating tank where he cooks it with sodium hydroxide. So the ratio of sodium hydroxide to the switchgrass, we figured out the right ratio for that, the amount of water. But just brings it to a boil, and it's
6 hours.
And we found 6 hours is probably could lower that, but that works. 6 hours works, and almost immediately the water is a aqueous suspension of the switchgrass, and the sodium hydroxide is in solution. It turns dark immediately, and that's the lignin coming out. So after 6 hours, we get the maximum amount of lignin out. And then you've been taking it out by just buckets full. And at that point, we acidify it. And you've just been using hydrochloric acid, uriatic acid. And that then precipitates the lignin. Then the precipitated lignin is collected by, Frank has a device here where the lignin, which is really a slurry at that point, a thick slurry, goes into this tank and then goes into the centrifuge, and that further spins down the material and removes additional water, and then the lignin itself is scraped out of the inside and looks like this. And that's lignin. Now the residual.
Can I touch?
Yeah. I've actually eaten this stuff.
Oh.
It's got a very earthy taste.
No chocolate?
It's not quite,
It's like
not quite chocolate.
Wow.
But when you think about it, when we eat vegetables, we're eating
Smells like
lignin.
chocolate.
Yeah, that's right.
It's a difference in concentration, of course, but it is pretty safe. Now
My face
the second, the other product that remains in here, or what we've been calling residual solids, which are essentially cellulose. When you cook it in the lye, you get some hemicellulose comes off, and that remains in solution. But the cellulose remains as a solid, and that's this material that results.
After you've cooked it in.
Yeah, right, after the lignin suspension is removed and so
Okay,
on, this
yeah.
is the solid that remains. And this is valuable in that the cellulosic material can be used for making ethanol. I mean, that would be the primary purpose for it. Could be used for fuel directly when it's dried. And in fact, part of the planning is that when this is run on a farm, that the residual solids, when dry, could then be used to heat the cooking pot. Right now it's using propane, which is expensive. But this then would burn and provide the heat. Alternatively, it could, when relatively dry, be pelleted or briquetted. And in that condensed form, could then be used and shipped to a cellulose producing facility. As you know, right now, DuPont is building a very large cellulosic plant out in Nevada, in Iowa. And part of their effort is to secure farmers in the area to provide switchgrass. So they're going through, and there was actually a webinar that they produced showing good agricultural practice so that the fields themselves don't, this is corn stover, not switchgrass, they're using corn stover. The fields themselves are not eroded and so on by that process. But it would be possible to take this material after it's briquetted and then ship to like a DuPont plant, and they could just take the cellulose and dump it into their reactors. So that may be a way of utilizing the residual solids. So this will have a value itself. The lignin, what we are attempting to do with the lignin at this point is to formulate it as a liquid fuel. And I've spent just maybe almost 9 months or so trying different approaches to it with solvents and so on. And solvents don't work very well, but there is an approach that I've tried recently, which is not too far from biodiesel, but it's not the same. But the lignin that does remain at least in suspension, doesn't go into full solution, but it's suspended enough that Frank was able to put some of it. And do you have any samples? Do you have any samples left? No. Of what we call lignoil. That's the material that's formulated into his tractor, and the tractor ran on that. And the work now involves trying to increase or improve the formulation by increasing the amount of lignin that's in the liquid material and to keep it stable. So that work has to still be going. And we're applying for a PETA grant, a Pennsylvania Energy Development Authority grant for $500,000 to do work on the farm and to do work at our biorefinery, which right now is a very small facility. It's my garage essentially, and using that to buy equipment and to go from one farm, Frank's, to other farms in the area. And the advantage of this process is that it avoids the need to transport very low-dense switchgrass, biomass, corn silver, whatever it is, which is very expensive to transport. It produces material which can be condensed easily, or can be condensed to a much denser cellulosic material, or the very dense lignin material, which then can be transported much more easily. So the work can be done on the farm, and Frank has demonstrated that it is feasible to do it on a working farm, and to produce these materials that have value primarily as fuel potential components, or maybe other. The use of lignin now is being evaluated as a very valuable potential source of other compounds that could then be used in the chemical industry for various purposes. So we're at this stage now. With additional funding, we'll be able to finish the work or improve the work here, and then go to other farms and go from there. Any questions? No? Good. All right. Thanks. Yeah.
Thank you.